Okay, this video is going to be about how to use the t-table for confidence intervals. Okay, I gave out the t-table with your confidence interval packet. Okay, so it's quite simple using it for confidence interval problems that use the z-distribution. The problem will give you the confidence level, or it might give you the error level, and as I talked to you in class, the error level plus the confidence level equals 100%. So if we had an error level of 2%, our confidence level would be 98%. Okay, so if we know the population standard deviation, all we need to do using this table, which you will have on the final exam, find the confidence level here at the bottom. Okay, and directly above in this column, sorry, in this row, will be the critical value of z that you need to use. Okay, so for a 95% confidence interval, we use a z value of 1.96. For an 80% confidence interval, we use a z value of 1.282. Okay, now if we are using the t-distribution, it's slightly different. Okay, and I'll cover that when we come to a problem like that. So here's our formula for confidence intervals. Okay, as one student said, it's just like a recipe, and we just put in the ingredients. You need to know that not only do we call the plus and minus, not only do we call it margin of error, it can also be called half width. Okay, this is also known as half width, and you must know these terms. Okay, so yes, here's the formula again. Okay, you'll have this formula on your formula sheet, but they will not break down the variables in the formula. So we take the sample mean, and then we add and we subtract the critical value of z times the standard error. Okay, so let's just click ahead to this problem. Example 6. Okay, so we have a tire manufacturer considering a proposal to advertise the average durability of the company's tires. Records kept on a sample of 100 tires, so our n is 100, yield a mean of 50,000 kilometers. Okay, so that's a sample that has a mean of 50,000, so that's our x bar. Population standard deviation from previous studies is 5,000, so that's our sigma. And then they tell us we should have a 95% confidence level, and we want to advise the manufacturer as to the range of values for the average life of all tires. So we're going to construct a 95% interval. Okay, so our formula, x bar plus and minus our critical value of z times the standard error. Okay, so if we go, we want 95%. So we'll go to our table. 95%, the critical value of z is 1.96. Okay, it's just a simple matter of finding confidence level, and directly above will be the critical value of z. So 1.96, we'll go back to this. So our z value is going to be 1.96, and then we just slot in our values. So our x bar was 50,000. We're going to plus and minus 1.96. Then we're going to take that times the standard error, which would be 5,000 divided by the square root of 100. Okay? So what that comes to then is 50,000 plus and minus 980. Now why is my stylus doing that? Stop it. 980. Okay, now we need to remember that this 980, we can call it the half width. Okay, so if you were to get a question that just asked you, my God, that this really, really messy handwriting. If you were to get a question that just asked you to find the half-width, well, the half-width of this problem is 980, okay? But to make the full confidence interval, the range of values, we have the lower confidence limit, okay, which is our x bar minus our half-width, okay? And we're going to have the upper confidence limit, which is our x bar plus our half-width. So our lower confidence limit for this problem is going to be 50,000 minus 980, which gives us 49,020. And our upper confidence limit is going to be 50,000 plus 980, which gives us 50,980. Okay? So the range of values, the manufacturer can expect the tires to last for between 49,020, is this kilometers or miles? Yes, 49,020 kilometers to 50,980 kilometers. Okay? So confidence interval problems, it's really just a matter of pulling out the information. Okay, you have to know the formula. Actually, you don't have to know it because it's going to be on your formula sheet. Okay? You need to know lower confidence limit, upper confidence limit. Okay, you need to know critical value of z. And these critical values will be given to you, as I've shown you, on the table. Okay, so you've got to know how to use this table. If you don't know how to use this table, you are going to be in a lot of trouble. Okay, so that's how to do a confidence interval problem when we know